Right, let's make a start. Good morning, everyone. Thank you for joining our webinar today. My name's Kimberly. I'm part of the marketing team at the IFM and IFM Engage. Welcome to the session, Expanding Horizons Using AI in Road Mapping. Before we get into the content today, I'll just run through some housekeeping. We are recording the session today, and the link will be shared with everyone who is registered afterwards. Please use the Q&A function to pose questions for our speakers and panelists. We will have time for questions at the end. You can use the chat function if you have any technical questions, and we'll do our best to help you. So today we are joined by Andre Gomez from the Institute for Manufacturing, Dr. Diana Kripko from IFM Engage, the IFM's knowledge transfer arm, and Professor Maicon Oliveira from the University of Sao Paulo in Brazil. So here is the agenda for today's session. I will shortly hand over to Diana, who will provide an introduction to road mapping. We'll then hear from Andre about his ongoing PhD research for using AI to pre-populate roadmaps. We'll finish with time for questions, joined by Maicon on the panel as well. I do hope you enjoy today's session, and over to you, Diana.
Thank you very much, Kimberly, and good morning, good afternoon to everyone, wherever you are around the globe. It is great to see so many different attendees. And I'm very much delighted to have the opportunity to give a very short introduction to road mapping concept, and then also to give you kind of overall idea of how road mapping and digitalization can link together. So let's start with the first question, which is, what is road mapping and what are roadmaps? I'm sure some of you have used this concept many times, but maybe some of you actually come across it for the first time. So let's recap briefly on the definition. So a roadmap is basically a structured visualization of your strategy, of your strategic intent. And road mapping process is basically the process which helps us to create roadmaps. And what is very important about road mapping, that it supports alignment between different stakeholders by bringing the stakeholders together, making them work collaboratively. In some cases, maybe making them disagree first, but then actually leading to consensus. And having this consensus by the end of the day, it's very powerful because it creates buy-in, it creates commitment to whatever you have defined in your roadmap as your strategic milestones. And the roadmap basically summarizes all these actions and decisions which you have made, and basically resource allocation on how you plan to implement your strategy. I have one slide to briefly explain a very generic structure of a roadmap. And what you can see here is a roadmap structure. And what is characteristic to a roadmap is that on a horizontal axis, we typically have the timeline. And on the very right end of this timeline, we have the vision. So basically the question, where do we want to go to? What is a big vision? How does a successful future like? How does good look like to us, right? Typically, you will underpin your vision with different targets and goals, which are smart, which are tangible, and which are agreed by the group of stakeholders whom you decided to involve in the process. And then leading towards the vision, you have the timeline, typically consisting of short and medium-term and long-term time frames, so windows. And then we have different layers, which are basically different areas of information, which you need to consider when designing and defining your strategy. Let's start top down. So typically on the top of your roadmap, we will summarize everything around the question why. Why do we need to change? Why we require a transition? Typically, we will capture different macro trends and drivers. We will capture different market perspectives. For example, your customer and client requirements and kind of strategies from your suppliers, and so on. And also, of course, we will capture the business strategy, which you probably will have separately to your innovation strategy. In the middle layer of our roadmap, we will center around the question, what? What do we want to do? And this can be products, services, systems. Depending on the topic, it can be also around different initiatives. It can be around programs or projects, very much dependent on the focus and intention of the roadmap. And then on the bottom of the roadmap, in the bottom layer, we will typically answer the question, how? How do you want to achieve this? So what are the different capabilities and enablers which are relevant and important to have in place to implement your strategy? Typically, these are, of course, skills. There are different technologies and technical capabilities, infrastructure. It can be R&D. It can be also all other types of resources, such as partnerships, such as policies and governance, etc. And with our roadmap, so you remember I told you in the definition, we talk about visualization of the strategy. So with our roadmap, we basically tell the story, we tell the narrative of where do we want to go to, right? Where are we now? And what is the pathway towards the future? Yeah. This is a very generic framework, which means in every case when we apply it, we actually need to change and customize and adapt it to whatever the focus of the topic is. So when we talk about road mapping and digitalization, the relationship is actually twofold. On the one side, of course, it is a framework which you can use to, for example, design your digitalization strategy or your digital transformation strategy. It is a framework which can help to understand what are the different emerging technologies which may influence your business and your ecosystem. It is a framework which can help you to understand what is the value, for example, internal value of these digital technologies, which can help to improve your efficiency of your processes, operations, etc. It can be also external value. So these emerging technologies helping you to change your business models and to generate additional value to your customer, which will basically help you to secure greater competitive position and secure greater market shares. And of course, these emerging technologies can be a part of the how layer, for example. So they can be enabling you to do other different things which you have identified in your strategy. So this is one perspective. However, there's a second perspective, because actually we can use these digital technologies to help our innovation and strategy formulation process, right? So we can use these technologies in the road mapping process as such. I have one more slide to give you examples for both perspectives. So I already talked a little bit more detailed about the strategy and innovation for digital technologies. So the first perspective, and you see here a very, again, generic example of, for example, if you have a product which you aim to, or which functionalities you aim to enhance with digital technologies, and you, for example, have your digital transformation plan, and you're developing your project, your product, and you have different MVPs which you have defined. This is where you can use roadmap to show how you will move from one stage to the next stage of your product development process. Let's have a closer look to the second perspective. How can we use digitalization and digital technologies in innovation strategy? Well, first, and I think all of us have this experience of moving into the digital environment, as we do right now in this webinar. So in IFM, when the research on road mapping has started, you can imagine it was a very vibrant environment when all the stakeholders are brought into the workshop. people traveling all around the globe to discuss one particular strategic topic. They used a lot of posters, they used a lot of post-it notes. Recently, somebody told it's like a love-hate relationship to post-it notes. So lots of materials which is used and put around the room for people thinking like in a hackathon format about the strategic issue. However, now we can use digital technologies and basically run the road mapping workshops in digital format. And for example, Professor Oliveira here, who has joined us today as panelist, has done a lot of work about this topic in understanding how we can use big screens, how can we run actually online workshops with many different participants around the globe, and what are the different techniques and tricks and kind of frameworks and tools which need to be used and how they can be used to basically make this process collaborative, right? Because road mapping is about collaboration, but also to use the strengths of digital technologies in this case. And then there is another second example of how we can use digital technologies to support our innovation and strategy formulation together with road mapping framework. So remember when I introduced the generic framework, I introduced the different layers, so different areas of information. And one question you may ask is, okay, how do you actually get this data? And there are different approaches to how you can get this data. One approach is do it completely expertise-led. So you invite your stakeholders who are experts in particular areas, and they're able to contribute based on their expertise, the relevant information. So for example, the market information will come from your marketing department, who have done all the studies and they understand your ecosystem very well. Everything around suppliers will coming from your procurement department. Everything around technologies will come from your engineers and from maybe your IT department. Let's say as an example. However, the second kind of extreme option is to use AI, to use other digital tools to populate, to collect, to analyze and populate your roadmap with information, right? These two approaches, so expert-led and kind of AI and digital technology-led approach to population of a roadmap, they are actually not opposite of each other. So in practice, when we do road mapping, we actually increasingly merge them because there are strengths on both sides. And the question is, how can we leverage the strengths and generate additional synergies using both experts' opinions and views and knowledge, but also the strengths of, for example, AI enabling us to gather lots of data, big chunks of data, and also to analyze it maybe in a bit more faster way. So today's session is very much focused on understanding and leverage the potential of AI in helping us to populate the roadmaps. And this is a topic which Andrei will deep dive in today. And at this stage, I will just hand over to you, Andrei. And
okay, thank you, Diana. Yeah, I'll share now. So, as Diana was saying, the focus now is about the pre-population of roadmaps using AI. I'm André Gomes, I'm a PhD student, and I'm a visiting researcher in the Institute for Manufacturing in Cambridge. So we are going to expand the horizons and learn how to use AI in road mapping. I'm going to explain firstly the objective of this. So our objective is to show how artificial intelligence can be employed to extract data from text sources for the purpose of pre-populating roadmap. And why text sources? We choose text sources because we have access to large databases, and we have very high quality databases that talk about a very diverse range of topics. So we can have access to thousands or even tens of thousands or hundreds of thousands of text sources. And the AI tool is capable of analyzing those sources way faster than humans would be able to read them. And that's why AI is specifically suited for this type of analysis, of helping in the pre-population step, of helping set up which would be the strategic objectives that will compose the roadmap and later can be utilized to help in workshops. what method will we do? How then do we extract these topics and describe them automatically using artificial intelligence? We will explore that now and then understand how better we can integrate this type of methodology into road mapping. The first component is pre-trained language models. Pre-trained language models are what? They are a subset of what are called neural networks. That is a part of artificial intelligence designed for processing and understanding textual data. These pre-trained language models are the basis of all that we interact with AI today in terms of ChatGPT and all these tools. They are trained in vast amounts of data, trillions of text sources. And these types of model, they understand these text sources way better through this neural network approach that is shown here. And then they can understand how texts are compared to each other. They know, let's say, that a glass is on the table is close to we are in a room, because these are similar topics. And distance, let's say that traveling to space. So it's able to compare sentences, it's able to compare texts and know the similarity between them. And through that, we can do exactly what we're going to do to better understand texts. And what is that? That is called topic modeling. So we can go through the whole textual database. We can look at through tens of thousands of texts and do topic modeling. That is a technique for discovering the thematic structure in a large corpus of text. So through that, we can see in the right, in the figure, that we can separate the text into several themes that go from science fiction to crime novels. Maybe we can see better on the left side, the non-fiction, green part, and in the right side, the science fiction. So it's able to automatically cluster the data, separate the data into several clusters, several topics, and these topics, we can then later describe them using large language models as well. So let's understand how this happens. Firstly, we have a large number of documents. Let's say that we have hundreds of thousands of documents. But then which would be like the most representative documents within the topics extracted? Let's say that we've extracted from 10,000 documents in total, we extracted 30 topics. In each of these topics, maybe there are 1,000 documents, maybe less, but some are more representative of the topics than others. So when we have these 30 topics extracted using AI, all done automatically, we can use those topics to extract the most representative documents to help us name the topics. Because firstly, we just have the knowledge that the data should be divided into 30 topics. But what are these topics about? We will use representative documents to know more about them. But let's say that we have 3 representative documents. Well, maybe they are not enough to describe the topics in depth. So we will combine that with what we call representative words. We extract the most representative words for each topic using statistical counting techniques to see the words that are most common within the texts of the topic. So we can go through the thousands of texts and see, let's say, in the example, the reinforced, laminated, and pinus are more common than the ones at the bottom, anatomic, isolate, and wood-based. And through that, we can better understand what the topic is about by knowing which words occur more often within the topics themselves. And how do we combine this knowledge about the representative documents with the representative words to create this description of the topic? Well, we can use large language models. Here we can use ChatGPT, or we can use any type of open source model as well, like Llama 2 or Llama 3 now, and other models like that. So this is an example prompt, a simple prompt that works really well given the right data sources. We can ask the large language model prompt for topic description based upon the topic is described by the following documents, the topic is described by the following keywords, and based on the information above, extract the concise topic label in the following format, topic label. What this does is extract very precise topic labels and in a very reliable way. This avoids hallucinations, and in general, it gives very precise topic labels, as we will show later. So when we do that, the language model does not hallucinate what the topic name is. No, it creates based upon data, based upon the documents that were really representative of the topic, and based upon the keywords that were very, very frequent in the topic. Now we will see how we can integrate that better into road mapping. So let's see a framework to apply artificial intelligence in road mapping. The first part of doing any type of data analysis is having a repository for a specific theme. And we use data mining to get this repository. And which types of repositories can we get? Well, many types. Maybe the simplest one would be scientific databases. We can go through them, pick thousands of articles, and do it all automatically in a matter of hours or even minutes to extract the whole information. But we shouldn't stop there. We can go to many other types of databases. We can use news sources, we can use PDFs, we can even use social media like Twitter, Reddit. We can use reviews in products. Maybe you're very interested in learning more about what people are saying about your products, about your competitors' products. We can do this type of analysis as well. And we can go even beyond that. We can transcribe data from audio data sources like podcasts and YouTube and have this as a data source. So anything that we can turn into text eventually can be turned into something that we can analyze. So here we can see how rich the database is and how specific to the theme at hand it can become. So that's a high quality and very, very big database. After that, well, we use the model to extract the topics using a pre-trained language model. Remember that language model that I told about? It knows which things are similar to each other and which things are distant. So it's capable of extracting specific topics and dividing the thousands of data sources that we have in few topics that we humans can understand really well, using AI to help us do that. And then after that, we will go to describe these topics. Not only we will know how many topics there are automatically, we will have descriptions, very precise descriptions of them, so that we can use those descriptions to help us populate strategic roadmaps and help us increase our strategic advantages. So after we do that, well, we should discuss these results with experts to pre-populate roadmaps. We can show them the results, we can show which topics which happen more or less in the documents, which have a higher or lower frequency, and help them to decide in which time frame the topic should go. Maybe if it is a very high frequency, it should go more in the beginning, but maybe not, depending upon your company. Maybe it should go more towards like some years from now. So we have to have always this contact with the humans to do the workshops based upon these data sources and this data analysis. After that, we can review the repository based on an expert feedback and eventually feed that back to build a repository for a specific theme. So we don't have to run that only one time. We can run that many times. We can update it constantly. Let's say we can run updates every month, every week, maybe every year, maybe every 6 months, and have a continuous support of strategic decision-making with data analysis together with workshops. So we can know when we should update and know which databases we should update together with the experts. So it's a process of continuous improvement using AI, using the best data sources that are discussed with the experts, and using the experts to better understand the results and apply them to real case scenarios of strategic decision-making. Let's see how this happened in a more practical thing. So here we have an illustrative case. We applied AI-driven topic modeling in an illustrative case about hybrid vehicles. So let's see how this can happen in a very practical way. Well, firstly, as previously mentioned, we have to build a repository for a specific theme using data mining. So we can collect data specific to hybrid vehicles, let's say from a scientific database. The advantage of scientific database is that the data is structured, so we don't have to spend as much time cleaning the data and preparing the data for further analysis. But at the same time, as I said, we can use many other types of databases. But here is a simple thing. We took the articles that were published from 2023 onwards, and we just typed hybrid and vehicle, and then we extracted these documents and run our analysis. And what does the analysis do? Well, as previously mentioned, they extract topics using a pre-trained language model. So we run a topic model analysis about hybrid vehicles using AI. As you can see in the example there, we have the original cluster data, and then we have the clusters, the topics divided, let's say, in 3, maybe 30. The AI will automatically decide the number of topics given our range. So if we want, let's say, about 30 topics, it will decide maybe 35, maybe 25. We can tinker with that if we want more topics or less, but the AI will help us decide that automatically as well. So after we know which documents should be in each topic, and we know how many topics there are, what do we have to do? Well, we have to describe the topics using large language models. And how do we do that? As previously said, representative documents. Let's take a look at this real case example. So the first phrase is, in this paper, we propose two energy management systems applied to two hydrogen hybrid vehicles. Talks about plug hybrid electric vehicles and range extended fuel cell hybrid vehicle. Well, the second phrase is, this paper investigates an integrated energy management strategy to improve energy efficiency. It talks a little bit about proton exchange membrane fuel cell as well, and intelligent fuel cell battery hybrid vehicles. So maybe energy management, well, it's hard to guess based upon only the documents. And there, where it comes, the keywords, they make it way more clearer. So we have fuel cell, cell hybrid, battery, energy, consumption, hybrid, hydrogen management. We have a better idea of how it should go. But if we are doing that as humans, it's kind of complicated to make a decision. So let's ask a large language model like ChatGPT based upon these data sources to answer. So what would be? Well, maybe managing hybrid vehicles with fuel cells. Well, it reflects really well the keywords, it reflects the documents, and there we have a name of the topic and a description of what it does. But we can go a little bit beyond that and know how many documents are in this topic. So in this topic, we have 63 documents. Okay, this is one, but can we do more of them? Well, of course we can. So the second one, let's say as an example, would be thermal management of battery systems. It has 30 documents, so less than energy management in hybrid vehicle with fuel cells. So maybe energy management is more frequent in scientific articles than thermal management. Well, that's interesting, right? And we can see that the keywords really reflect the second topic, like thermal, temperature, battery, thermal management, and etc. The same thing can be said about the documents. To achieve this purpose, the first one, an integrated thermal management system model with different control strategies. And it goes on to talk about thermal management system. And the second one talks about peak temperature of the battery. So we can see that the naming of the topic, the description of it is really well fundamented upon the documents and upon the keywords, avoiding hallucinations and making sure that the topic is well described based upon the data. And then we can use these types of documents, this type of topics as well, to create the roadmaps. We can pre-populate the roadmaps based upon that. And how do we do that? Well, we discuss the results with experts to help us pre-populate the roadmaps. They can see that maybe some topic is more frequent, and they were expecting that, and this topic was really important. So maybe it should be tackled very soon, but maybe for their specific case, not that much. But it's interesting to see anyway the frequency of the topics, the names of the topics. Maybe some topics are present that they did not expect. Maybe some topics are not present that they expected, and they want to understand better why that happened. So we have another type of source of information, not only experts, but the AI-based analysis in thousands of texts, or maybe even tens of thousands. And then we can use that to pre-populate the roadmaps. But eventually they may want some changes in the data. They may want to rerun the analysis in a different data set or a different time frame. And then we can review the repository based on the experts' feedback. So based upon what they say, we can build different data repositories. Maybe we have that hybrid vehicle analysis using scientific data, and we want something more related to news sources. Well, we can run that and compare the results. Maybe based upon social media, we can run all three of them, and with each one of them help populate, let's say, a part of the strategic roadmap. And with all of these data sources, these rich and very specific textual data sources, we can build a well-based upon data, big data analysis to help us in a strategic decision-making. So we use always the experts' feedback to help us in this continuous improvement process using data and experts to improve strategic road mapping. So let's see some real case results from a real industrial case. So this was applied in a real case, and we have the results of this application of topic modeling. Use ChatGPT to support roadmap in an age tech firm. So how did we go in these results that we applied in this specific case? Well, the first thing is that we had in the end a collection of 99 topics. And how many of these topics came from the topic modeling results? Well, we can see that 44% of the topics are from topic modeling. So almost half of the topics came from the pre-population step. And that helps a lot in two ways. First, it saves a lot of time. And beyond that, it gives another type of data source, another type of analysis that can go beyond the experts to help them make these types of strategic decisions, to make them road mapping process. And beyond that, 79%, almost 80% of the topics from the results of the topic modeling were used in the final roadmap. That shows that these types of pre-population steps, they are really useful. They are really used in the real world to create the roadmaps. So in here, we can see a clear example about the advantages. We have time saving, we have a different data source, and we have something that helps begin the road mapping process in the workshops, because we have something that came from data that is reliable and that can be utilized to help in the strategic decision making. And we can go beyond the common data sources that are more table-based into the textual data sources that, as I said before, are very rich, very specific, very diverse, and can be adapted to every single type of circumstance. And which would be the feedback from participants that we could clearly see when we applied these types of results? Well, we've seen the potential then of artificial intelligence to discover new topics related to each tag. So we can see the artificial intelligence going through the documents, and that's the great advantage. The documents, this rich data source, analyzed automatically, can help us discover topics that we weren't really expecting. Maybe one topic, maybe 2, 3, 4, 5, but maybe these topics can be of fundamental value in the road mapping process. Maybe they can be very important for strategic decision making, and they weren't expected within the company, or maybe they weren't that expected by all the experts. And by bringing that up, we can have a competitive advantage because we have access to these data sources in a very precise type of analysis. What else? Well, we can as well go beyond only creating new topics and seeing new things. We can substantiate with data key issues that we already know in the HTech world or any other application whatsoever. So some topics that were maybe considered important can be now substantiated with data. Now we have data to say that this topic is really important. We have this type of data-based, AI-based analysis. And at the same time, maybe some topics weren't that present and they weren't considered as important. So then we can have a better peace of mind, knowing that maybe this isn't really important, we should focus in other things. So it helps us prioritize our road mapping process. It helps us select which things should be in our strategic minds when we make decisions. And it does all of that based upon rich data sources and great artificial intelligence-based analysis. But of course, when we do these types of applications, there are always limitations. So which would be the limitations of artificial intelligence in road mapping? Well, the first one would be database accessibility. We have some challenges in connecting to and querying databases effectively. Maybe some scientific data sources are easier for the academic world. Maybe they have some difficulties to be accessed in other departments. But we have other data sources like, say, Twitter, where we have to deal with the API, all the programming necessary, and we have to pay to utilize it. And we have complex data sources like PDFs that we have to download, not only analyze, but we have to find a way to download them. So we have to have a specific knowledge about how to utilize this database effectively. Maybe we can do with 1,000 scientific articles, but maybe with 20,000 is a little bit harder. So we have to acquire this knowledge and use it. And a second problem is data extraction. Well, there are difficulties in retrieving data from non-traditional data sources such as PDF files and other document formats. Or maybe we can read the PDF file, but what about the layout? What about knowing that this is in the introduction of a scientific article, or maybe in the method or the conclusion? What about knowing that this is a table or not, this is a figure or not? We have to run then an AI-based analysis as well to help us extract the data sources correctly from PDFs. And the same can be said about even more complex data sources as podcasts. How do we know which one is the speaker, which one is talking about what? So during this data extraction as well necessitates some specific knowledge about this type of data extraction and data mining component that is foundational so that we can have a big data sources that is specific and good to do our strategic decision making and road mapping. And beyond that, we have what we call prediction biases. We have, of course, the presence of inherent bias in model outputs, which can affect decision-making process. So these types of large language models in general, ChatGPT and the others like it, they have biases, and it's complicated to deal with them. Maybe the best way, or the only way, would be to deal in the way that we're trying to deal with here. Well, giving data sources so that it can do the answering, do the creating based upon data, based upon documents, based upon keywords, all of the things related. That diminishes the biases of it, but we have to always be careful with it. And the same thing is true about the model reliability and safety. We have concerns regarding then the ethical implications, and especially the potential errors in model predictions, and we should avoid them. These errors sometimes are seen as common from these large language models, but they are common if they are not based upon data. So if we give great data to the large language models, it tends to do things very precisely. But that must be done with care, not only the data selection process, but how do we best feed that into these language models to have this reliability so that we can trust the results that we are using to build our strategic decision making. That demands some specific knowledge about how language models work and how our databases work to extract the best data from it and to use this data correctly with the language model to generate the best results. What else? Well, we have hardware dependency. It demands a high processing power to run this model efficiently. Maybe if you want to run locally, let's say that you want to run an open source model that runs everything in your own computer, well, we'll have to have a very good computer. So we have to buy these types of resources, or we'll have to rent these types of resources. But maybe you want to run like a ChatGPT-like thing, and then you have the problem that you have to pay for it, of course. So we have always this hardware dependency that is something common for these large language models, given how much data they utilize, they have a high hardware utilization rate. And lastly, we have privacy concerns. We have concerns about the privacy of sensitive data, especially when dealing with closed source models. Well, we have contracts we can maybe trust, sending data to other sources, to other companies, and trust them with privacy. And that's a way, and that may work, but maybe we want to run the models in our own computers or in our own databases in our own way. And we can do that as well with local models. They are a little bit smaller than the large language models as ChatGPT, but they can be run locally in our resources, in our computers, in our data centers. They can be run, so we can try to avoid these privacy problems running these models locally, but at the same time, we can maybe run a contract, maybe create this type of trust related to privacy. But it's always something that we must be attentive towards, because it is like sharing data that may be very important for the company. And what are the others? Opportunities for future applications of AI in road mapping. So here we explore some techniques that go a little bit beyond what we showed already about the topics to better understand how we can use that to create this pre-population step, this pre-considered topics to further create the strategic roadmaps in workshops. Well, the first one would be called supervised topic modeling. And what is that? Supervised topic modeling allows us to steer the topic modeling to results that follow any labels you might already have. So let's go back to the hybrid vehicles example. Well, maybe you want to know a lot about batteries, not a lot, like batteries in hybrid vehicles. So you take the same documents, but you tell, okay, AI, try to find topics that are more related about batteries in here. And it does that. It gives more topics that are more related about batteries using the same data source. So we can direct the analysis of the AI toward a specific topic that we want in the data sources that we've chosen. Beyond that, we can do what is called incremental topic modeling. So we have the possibility of updating the topic model with data on which it was not trained before. So let's say that we want to run monthly or bi-monthly or yearly updates. We can do that. We can pick the model that was already done, put more data into it, and see how the results changed or how the results stay stable. So we can do this type of updates constantly and have a data-based update of our roadmaps that can maybe tell us, oh, maybe we should do another workshop. So we can have this data helping us do these types of analysis. Beyond that, we can see how the topic modeling results develop over time. This method does what? It allows you to understand how a topic is represented across different time frames and how the topic evolves over time. So maybe we want to know about the topic about thermal management in 2022, 2023, 2024, and see how it changed, how the keywords changed, how the naming changed. We can do that as well. And we can go beyond that to see how it grew, how it decreased. So we can see topics that are starting to grow. We can see topics that are stable that maybe we have to give attention to. We can see these developments of the topics over time as well then. And beyond that, we can do what's called a class-based topic modeling. We have a way to determine how certain topics are represented over different classes. Let's go back again for the hybrid vehicles example. Maybe we can compare news sources with academic sources and see the differences in it. See the gaps between one and the other, and maybe opportunities in there. Maybe some scientific sources are talking a lot about something that is not mentioned in the news that may be of interest to us, or maybe the opposite, or maybe they're talking about the same thing. And that shows that maybe that's really important, right? And we can do sentiment analysis of topics as well. Well, we can do sentiment analysis as a technique of identifying and categorizing opinions expressed in text to determine the writer's attitudes towards a particular topic. So we can know if the topic is positive or negative. We can know if specific components of the topic, let's say the battery, is positive or negative. And we can even look at emotions, if it is more towards angry, happy, curious. We can do all this type of sentiment analysis to better understand what is happening within the topics itself. And lastly, we can create reports based on topic modeling results. So we can create AI-based reports about the topics using the data contained in the original repository. So we can go a little bit beyond only having the topics, but having, let's say, below it, some summary of some representative documents that talk a little bit about the topic. And then you can go and read that summary and maybe go through the references. And then we can have, let's say, 20 pages with 30 topics talking about each of the topics a little bit, so that we can go a little bit deeper and maybe help in the decision making on where this topic should be in the road mapping. That is it about applying AI in road mapping. Any questions?
Thank you very much, Andre. It was very insightful to hear from you, and also different concepts and aspects of integrating AI and enhancing basically road mapping framework. There are quite a few questions in the chat. So maybe I just start in chronological order and pose the questions which were shared by our participants here. So the first question is about, do you have any recommendations on how we can choose the representative documents?
Oh yeah, that is done quite automatically, because when the topic is created, it knows, let's say, that the topic is here, and it knows like the documents that are most central to it. And that can be done automatically. We can just extract the ones that are most representative to the topic. So the AI does that for us. Yeah.
Okay. We have quite a few questions from Christian Rasmussen. I will start with the first question, which is about, so Christian is referring to your presentation and saying you show how well categories and described each category. When placing the topics on the level in the roadmap, you rely on experts. So can you use AI to categorize topic on strategic, product, and more detailed level?
Yes, we are exploring this possibility as well. For now, our focus is in creating the topics, but we are exploring and running this possibility. We are running models so that we can better know how to extract the topics and know where to position within the roadmap in terms of strategic, product, or a more detailed level. So it's a work in progress that we are going through, and we are having some promising results.
Mm-hmm. Thank you. There is a second question from Christian, and I think maybe Maicon, you can give an answer to it, because I know you did a lot of research in this area. So Christian is saying physical road mapping can be biased by the knowledge level of the people in the room. So is there, in your experience, an even out effect by using AI to reach deeper knowledge on all topics?
Good morning, everyone. Thank you, Christian, for your question. Yes, of course, we have always some bias. And when we get the background of knowledge from a large data set, we always get new insights, and we also find ways to leverage people on the same knowledge. So that makes clear when someone is driving too much to different sites. So you are right. So it's possible to follow in that way.
Thank you. Andre, do you have anything to add as to this?
Well, yes, I think the AI can help in level, but as well it brings another, let's say, an expert, a different type of opinion. So I think at the same time that it may create a database analysis, it brings another opinion. So I think in that way it's very good in terms of increasing the reliability of the road mapping process in the end.
I think you also showed it with your example with the electric vehicle, right? Where you showed how much percentage of data came from actually AI, how much was contributed by experts, I assume. And then you showed how much of data which came actually from AI, which was a big portion of it, was taken forward for strategic considerations.
Yes.
Okay, let's move to the next question. And there are actually a few related questions. So I will read the next question, but then I see in the chat there are a few other questions which relate to it. So apologies, I will jump a little bit. So next question is, many of written communication is identifying the sentiment of a statement, for example, in academic papers. How could we distinguish between someone is challenging a statement or building on top of it? And how would you suggest we consider this sentiment for our road mapping topics and decisions derived?
So this is a little bit of a complicated question, like to go through the document itself and to know if it's challenging or if it's building on top, we'll have to use all the data sources, and maybe we can use like what we call like using cosine similarity, knowing if it is close to challenging. So we can put the word challenging and see if the document is talking more about challenging or if it has words more related to challenging. We can use the pre-trained language models that we talked about to help us decide in that. And we can use sentiment analysis, maybe with challenging sentiments like anger or things like that to help us do that. So there are these possibilities, but in terms of applying it in practice, it's still a work in progress, going through these very specific details. But basically we use these types of analysis. We use the pre-trained language models to make the comparisons together with the sentiment analysis to help us know what the topics are talking about. And then we can know if this topic is challenging and how we can position in terms of challenging in the roadmap or maybe in building on top of it. That's how I think it can be done.
Mm-hmm. And
Diana, if I may add,
please. Yeah, please.
Just to say, the data source is very important in this topic. So when we use academic writing or academic papers, there's not so much explicit on sentiments. It's more impartial because of the style of academic writing. So sometimes it's not so easy to gather what's the real opinion in that. In contrast, when we use social media, that's much more clear. So it's easier to understand the sentiments when we use data from social media. But thank you for your question. It's very insightful. We will consider that in our future work.
Mm-hmm. And maybe related to it, so Johanna Lambert is asking, can AI access document databases that typically need a subscription? For example, Euromonitor or Statista or others?
Well, to use databases that need a subscription, the best way would be to get some type of what is called API. So it connects directly with the subscription. Most likely you have to pay something for it, and then you can utilize the data source. So it's better to I think, contact the companies for that purpose. I think so. Yeah.
Mm-hmm. Okay. There's one more question from Christian. So he's asking, how have you set up operation of the AI and database system you describe? And at what service level and scale is the system in operation now? And what do you plan for it?
So for now, the system works really well with scientific databases. We are expanding towards PDFs and other data sources. We've run the analysis as well in Twitter data and some PDFs, but we are trying to expand, like in terms of PDFs, we're trying to expand so that we can look into hundreds and thousands of them. But in terms of scientific articles, we can look at, we've done analysis with hundreds of thousands. So we use the API from Scopus, we get this data, and then we just run the analysis through it, and we get the results that are necessary. And for now, we are applying that in IFM, specifically in IFM Engage, to generate topics. and help us create these pre-population steps of strategic roadmaps. That's what we are doing right now. So it's functioning now, and we are using in real case scenarios together with IFM Engage.
Thank you. Maybe the next question for Maicon. On the road mapping process itself, do you propose to move directly from AI pre-population into the interactive road mapping workshop? Or is it necessary to further prepare the workshop with additional expert interviews, for instance? What is your experience? So this question came from Victor Prodonov.
Good morning, Victor. That's also a very good question. It depends on the case. We need to understand more who are the experts involved in the process, who are your stakeholders. So sometimes it's possible to go straight from the AI preparation to the workshop. In other cases, we need to work more in collaboration with some experts before going to the workshop, but it depends on the case. Right now, what we have been seeing in our case is that AI is progressing very fast. And if you have the right data, you can really start the workshop with very good pre-population. But right now, since we are still learning as part of our research process, we always tend to involve experts in the pre-population as well to make sure we have the right direction that we are extracting for data before going into the workshops. That's the way we are doing right now, but we do believe that in the future, if we will have the right data and the right approach for the workshops, we can go straight from the pre-population with AI to the workshop itself.
Yeah, and maybe from a practitioner point of view, so I do quite a lot of road mapping work on different topics. It also depends a little bit on how you plan your roadmap, like overall road mapping process. So in many instances, we actually have not only one workshop, we have actually several workshops, like a workshop series. And there, why do we have workshop series? Because we actually go through a phase where we collect data, we analyze data, we review data with experts, we gather additional insights, we go away, we do again some analysis, maybe collection of additional data because there were some gaps, and then we gather again with experts. So, and then we go in this iteration basically based on the subject we're looking at. From my experience, I think you can merge AI analysis in any of the stages. So you can use it for pre-population and, you know, present experts basically with initial set of data, which is quite helpful. So typically in our road mapping workshops, we typically will gather data ahead of the first workshop. So we either do expert survey initially, or we do a lot of desk research, or nowadays we can use AI. Right? And sometimes we can do all of it together, right? So it's always good to go into workshop having already a set of data, and then you gather it with expert, and then you can use again, for example, AI to analyze and add or close the gaps. Okay, I hope it helps with your question. We have then another question from somebody anonymous. Are you planning a follow-up hands-on workshop where we can apply scenarios to our respective fields?
Well, we can see about that. What do you think, Diana?
Yes, I think it's a good suggestion.
Yes.
So put to the team for more ideas. Thank you very much. Let's discuss. Okay. What are the limitations of tools such as ChatGPT, and what level of investment will be required to go to the next scale and build a model with thousands of data sources, basically more complex data repositories? Is this feasible for smaller companies?
Well, in terms of using thousands of data sources, if you're talking about thousands of texts, we have run that with hundreds of thousands. So it already works really well, and it's all set up. And in terms of use by smaller companies, yes, it's feasible. That especially if we go into contact, let's say, with IFM Engage, we can help you apply these types of tools. But I think it should always be together with the specialist, because then you can have reliable data analysis. But yes, you can do this model connected with several data sources and then run it and have the results. So I think, yeah, it can be used with smaller companies as well.
Mm-hmm. And Maicon, what is your experience? Because you also worked with many different sizes of companies and you actually published the papers of comparing different types of groups and companies. So how do you see it?
Thanks again, the anonymous participant, for the questions. I see that smaller companies, they tend to use models that are already pre-trained. I see that's not feasible really for smaller companies to run and to create specific models because the investment is very high. But I also see that the companies like Google, Microsoft, or OpenAI, they are making ways of creating very accessible models for smaller companies to run and to fine-tune their applications based on large language models from proprietary companies like that. So it's very feasible for smaller companies. They just need to understand what's the best way to approach the problem. Okay. And the previous question that discussed about the hype, that's very important. The hype is really passing by right now, and we see a lot of real research and we see a lot of work being developed to understand what really we can extract, what value we can really extract from using AI for our work in any specific domain. So we see now a lot of progress in that sense. And I do believe that the AI and related tools, they're going to become some kind of tool that we can use to support our work in any sense and also in roadmap specifically.
Okay, I think we have 1 more minute for answering question. I think actually Maicon's answer has kind of related to Philip's question as well. So I think it is addressed. Let's move to the question from Ahmed, who is asking, can we identify different problem formulations or alternative perspectives on the problem framing using AI before roadmapping the solutions?
Yes, I think that a clear way to do that is when we talked about class-based. So we can see different perspectives when we take different data sources. AI is really based upon data sources. So to see different problem formulations, to see alternative perspectives, what we recommend is basically using different data sources and going through them. Maybe 1, 2, 3, 4 data sources, and then we can run the model in each of them, and that will give us different perspectives.
Okay, and maybe very last question with very short answer. How reliable is it to ask AI for future market predictions or trends?
Yeah, in this case, like in this type of analysis of data, what AI does is really understand the data, and that can help us make decisions. The same way that, let's say, a chess using AI is capable of making great decisions based upon what happened in the past. This type of AI can make great decisions upon what happened in the past. It cannot tell you reliably what exactly will happen in the future, but as we humans can't as well. So basically what it can do is use more data sources and use it really well, very specific data sources to help in our decisions. And that can help us make predictions about the future, make bets that we can choose, let's say, a specific thing to do because it's well based upon data. And that, I think, for now is as far as it can go. Like it can do data-based analysis.
Yeah. Thank you very much, Maicon. Thank you very much, Andre. I think we are at the end of the session. We have just one small piece of information, and therefore I hand over to Kimberly. Thank you very much from my side.
Thanks, Deanna. Thank you everyone for your time today. I just wanted to highlight a few ways in case you weren't already aware of how you can engage with IFM specifically on road mapping. We have 2 short courses coming up where we teach road mapping concepts. One is on strategic road mapping, the other focuses on product technology road mapping. Both of these are online, but we do also run a face-to-face course as well, delivered in Cambridge. There'll be dates available for that later in the year. You can find out more about those on the IFM Engage website, which is just there for you. We also offer consultancy services to support your organisation, as well as in-house training at your organisation's premises, or a combination of both. There's more information and case studies about our road mapping applications on the IFM Engage website. That just leaves me to thank our speakers and panelists for today's session. Very informative, and thank you all for your participation and so many great questions. So that just leaves me to say enjoy the rest of your day. Thank you very much.
Thank you, everyone. Bye-bye.
Thank you, everyone.
Bye-bye.
Bye.